Fixed-wing airplanes are the aircraft most people picture first. They have rigid wings that do not flap or spin. As the plane moves forward, air flows over and under the wings, creating lift that holds it up. Engines provide thrust, and tail surfaces help the pilot steer and stay stable. Airplanes come in many sizes, from tiny trainers to giant airliners and military jets, but they all use the same basic idea. Forward speed turns wing shape into lift. One interesting fact is that the world's largest passenger planes can carry hundreds of people across oceans, yet the same lift principle also works for small bush planes that land on rough dirt strips in remote places. Gliders are fixed-wing aircraft designed to fly without an engine, and sailplanes are the high-performance version built to stay aloft for long periods. They launch by tow plane, winch, or sometimes from a slope, then use rising air to keep flying. Warm columns of air called thermals, ridge lift from wind-hitting hills, and wave lift near mountains can all carry them upward. Their long, narrow wings reduce drag and help them glide very efficiently. Pilots must read the sky like sailors read the sea. A surprising fact is that skilled sailplane pilots can travel hundreds or even over 1,000 kilometers in one flight, using only natural energy from the atmosphere and no fuel once airborne. Helicopters are rotorcraft that use spinning blades on top to create lift and thrust. Each blade acts like a rotating wing. By changing the angle of the blades as they spin, the pilot can make the aircraft rise, hover, move sideways, fly backward, or turn in place. A tail rotor, or another anti-torque system, stops the body from spinning the opposite way. Helicopters are incredibly useful where runways are not available, such as on ships, mountain rescue sites, city rooftops, and offshore platforms. One remarkable fact is that helicopters can perform life-saving jobs in places airplanes cannot reach, including hovering over a crash site to lower rescuers directly to people in danger. A gyroplane, also called an autogyro, looks a bit like a small helicopter but works very differently. Its rotor is not powered in normal flight. Instead, a separate engine drives a propeller that pushes or pulls the aircraft forward. As air moves upward through the free-spinning rotor, the blades turn on their own and create lift. That means a gyroplane cannot hover like a helicopter, but it can fly slowly and land in a very short distance. Many are used for sport flying, patrol work, and aerial observation. An interesting fact is that gyroplanes are often very resistant to stalling in the way airplanes do, which gives them a unique safety advantage when flown properly. Airships are lighter-than-air aircraft that float because a large envelope is filled with gas, lighter than the surrounding air, usually helium today. Unlike a balloon, an airship has engines and steering surfaces, so it can move where the pilot wants, rather than simply drifting with the wind. Some are rigid, with an internal frame, while others are non-rigid blimps that keep shape from gas pressure. Because they can stay aloft for a long time and move slowly, airships are useful for advertising, sightseeing, and observation. A surprising fact is that modern airships are being studied again for carrying cargo to remote places, because they may move heavy loads without needing roads or long runways. Free balloons rise because the gas inside is lighter than the air around them, or because heated air becomes less dense than cooler air. They have no engine for forward flight, so they travel with the wind. Pilots control height by heating the air, releasing hot air, or dropping ballasts, and then choose wind layers moving in different directions. Hot air balloons are the most familiar, while gas balloons can stay up much longer. Flights are peaceful and quiet because there is no constant engine noise. One fascinating fact is that ballooning was the first successful form of human flight, long before airplanes existed, and people were already rising into the sky in the 1780s. Seaplanes are airplanes designed to take off from and land on water. Some have floats attached under the fuselage, while others have a boat-like body that sits directly on the water. In the air, they fly like other fixed-wing aircraft, using wings for lift and engines for thrust. On the water, the pilot must also handle waves, wind, and currents, which makes operation different from runway flying. Seaplanes are especially valuable in places with many lakes, islands, or little airport infrastructure. An interesting fact is that in parts of Alaska, Canada, and the Maldives, seaplanes are not a novelty at all. They are a normal, everyday way to connect communities that roads cannot easily reach. Amphibious aircraft are built to operate from both water and land. They may be amphibious seaplanes with retractable wheels in their floats, or flying boats with landing gear built into the hull. The key idea is versatility. One aircraft can land on a runway, a lake, a river, or sheltered coastal water. In the air, they work like other airplanes, but their design must balance the needs of both surfaces, which adds weight and complexity. That trade-off is worth it for rescue, transport, firefighting, and travel to remote areas. A neat real-world fact is that some amphibious aircraft can scoop huge amounts of water from a lake while still moving, then drop it moments later on a wildfire. Jet aircraft are airplanes powered by jet engines, which work by taking in air, compressing it, mixing it with fuel, and blasting it out the back to create thrust. Because they can produce a lot of power, jets are ideal for high speed, high altitude, and long-distance travel. Airliners, business jets, fighters, and many military transports all use this basic engine idea. Their wings still create lift like any other airplane, but the propulsion system is different from a propeller aircraft. One surprising fact is that large passenger jets often cruise high above most weather, where the air is thin and fuel efficiency improves, allowing people to cross continents and oceans in hours rather than days. Propeller aircraft use an engine to spin blades that pull or push the airplane through the air. Those blades act like rotating wings, creating thrust, while the main wings create lift. The engine may be a piston engine, common in small planes, or a turboprop, where a gas turbine turns the propeller. Propeller aircraft are often slower than jets, but they can be more efficient on shorter routes and better suited to small airports. That makes them important for training, regional travel, cargo, farming, and bush flying. A useful fact is that many propeller planes can operate from short runways where jets cannot, helping connect smaller communities to the wider transportation network. Supersonic aircraft are designed to fly faster than the speed of sound. At those speeds, air behaves differently, creating shock waves and much greater heating and drag, so the aircraft must have special shapes, strong materials, and powerful engines. Most supersonic aircraft have been military jets, though a few passenger designs have existed. They still rely on wings for lift and engines for thrust, but every part of the design is tuned for very high speed. One famous real-world fact is that the Concorde once carried passengers across the Atlantic in about 3.5 hours, roughly half the time of a normal airliner, making breakfast in Europe and lunch in America feel surprisingly realistic. Tiltrotor aircraft combine features of airplanes and helicopters. They have large rotors mounted on nacelles that can point upward for vertical takeoff and landing, then tilt forward for fast airplane-like flight. In helicopter mode, the rotors lift the aircraft straight up. In airplane mode, the wings carry most of the weight, and the rotors act more like propellers. This gives tiltrotors the flexibility of vertical flight with greater speed and range than a typical helicopter. They are especially useful for military transport and operations from ships or remote sites. An interesting fact is that tiltrotors can cover long distances much faster than helicopters, while still reaching places with no runway at all. STOL stands for Short Takeoff and Landing. These aircraft are designed to get airborne quickly and land in very little space. They usually have wings and flaps shaped to create lots of lift at low speed, along with strong landing gear for rough strips. Many use propellers because they provide good control and thrust at slower speeds. STOL aircraft are not a separate shape so much as a special capability, but they form an important class in real-world aviation. They are essential in wilderness regions, on islands, and in humanitarian work. A surprising fact is that some STOL planes can operate from airstrips so short that they look more like clearings or gravel bars than airports. VTOL means vertical takeoff and landing. These aircraft can rise straight up and land straight down without a runway. Helicopters are the most familiar VTOL machines, but some airplanes and advanced designs can do it too, by directing engine thrust downward or using lift fans. The challenge is that hovering takes a lot of power and careful control, especially during the change between vertical and forward flight. VTOL capability is valuable in crowded cities, on ships, and in places where runways are impossible. One notable fact is that some military VTOL jets can operate from small decks or damaged airfields, giving them flexibility that ordinary airplanes simply do not have. Human-powered aircraft are some of the lightest flying machines ever built. Instead of an engine, the pilot provides power by pedaling, usually turning a propeller through a chain or gear system. Because human muscles produce only a small amount of power, these aircraft must be extremely lightweight, with huge wings, careful aerodynamics, and very calm flying conditions. They take off slowly and fly at low speeds, but they prove that human flight by muscle alone is possible. A wonderful fact is that engineers and athletes have flown human-powered aircraft across significant distances, including over open water, showing how efficient a well-designed aircraft can be when every gram and every bit of drag matters. Ornithopters are aircraft that fly by flapping wings, copying the basic idea used by birds and insects. Instead of fixed wings or spinning rotors, a mechanical system moves the wings up and down or in a more complex pattern to create lift and thrust together. Building a practical ornithopter is difficult because the motion must be light, strong, and precisely controlled. But real examples do exist, especially in small experimental and research forms. They help engineers study natural flight and unusual ways to move through the air. An interesting fact is that some tiny ornithopters are designed to imitate birds or insects so closely that they can be used for research in places where a normal drone would behave very differently. Powered paragliders, often called paramotors, are among the simplest powered aircraft. The pilot wears or rides with a lightweight engine that spins a propeller, and a fabric wing above creates lift like a parachute shaped for flight. The wing inflates as air flows into it, and the pilot steers by pulling brake lines that change its shape. Because they are light and slow, powered paragliders can take off from open fields with a short run and offer a very direct feeling of flight. One fun fact is that many pilots launch on foot, meaning a person can literally run a few steps, lift off, and cruise over countryside with little more than a backpack motor and a wing. Hang gliders are unpowered aircraft with a rigid frame and a fabric wing, launched by foot from hills or by tow. The pilot hangs beneath the wing in a harness and controls direction by shifting body weight. As with sailplanes, lift comes from air flowing over the wing, and pilots stay aloft by using rising air from thermals, ridges, or mountain waves. Hang gliding offers a simple, open-air form of flight that feels close to soaring like a bird. A surprising fact is that experienced hang glider pilots can remain airborne for hours and travel long cross-country distances, all without an engine, using only weather knowledge, wing skill, and the natural movement of the air. Parachutes are aircraft in the broadest sense because they use air to support a person or load, though they are mainly designed to descend safely rather than travel far. Traditional round parachutes focus on slowing descent, while modern ram air canopies are shaped like flexible wings. Air enters cells at the front, inflating the canopy so it can glide forward and be steered with control lines. That makes modern sport parachutes highly maneuverable compared with older designs. An interesting real-world fact is that precision parachute pilots can land astonishingly close to a target, sometimes almost on a single marked spot, showing how much control a fabric wing can provide when designed and flown well. Uncrewed aerial vehicles, often called drones, are aircraft flown without a pilot on board. Some are controlled remotely by a person, while others can follow programmed routes or use onboard systems to stabilize themselves. They come in many forms, including small quadcopters, fixed-wing drones, and large long-range military or research aircraft. The basic flight method depends on the design: spinning rotors for lift, wings for lift, or a mix of both. Drones are used for photography, mapping, farming, inspection, delivery experiments, and emergency response. A striking fact is that tiny drones can inspect bridges or rooftops, while much larger ones can stay in the air for many hours, doing jobs once possible only with crewed aircraft. Hybrid lift aircraft combine two different ways of staying in the air, usually lighter than air buoyancy and aerodynamic lift from wings or body shape. Part of their weight is supported by helium, while the rest is carried by moving through the air like an airplane. This can reduce fuel use and allow heavy loads to be carried with less runway, or sometimes none at all. Designers are interested in them for cargo transport to places with poor infrastructure. They are not as common as airplanes or airships, but they are a real and important category. One intriguing fact is that hybrid lift concepts are being explored as a way to move oversized cargo to remote mines, forests, or disaster zones without building major roads first.